Hello and welcome to this tutorial. In this tutorial, I'm going to introduce the subtraction of vectors. So if you remember in the previous tutorials, the addition of vectors was covered and the formula for both triangle and parallelogram laws was introduced, and in two separate extension of tutorials I demonstrated how the formula is obtained. So in this tutorial I'm going to start introducing the subtraction of vectors. First of all, I remind you that in vectors we cannot follow the approach we use in the case of algebraic addition or subtraction. So, for example, the vector like S is the result of the subtraction of two vectors A and B. So I cannot subtract the magnitudes of vectors A and B. It is not accepted. So as it was mentioned in the previous tutorials, in the case of vectors we have to focus on the geometric characteristics of vectors, the angle between them, their tendency, and so on. But in subtraction of vectors, one important point is that it is following the addition laws. You may ask how. So let's consider this expression of A minus B, two vectors A and B. Can I rewrite this expression as the vector A plus the negative of vector B? In algebra, for example, we can write 5 minus 3 is equal to 2. This is an algebraic expression of subtraction between two numbers. 5 minus 3 is equal to 2. Mathematics allow me to write this expression in another way like this. So instead of direct minus sign, I add minus 3 on 5. The results are same. Both of them are equal to 2. But in the second one, I just added one more step of calculation. I don't want to imitate algebraic expressions in the case of vectors, but we can follow the same rule in the case of vectors. So when you hear the vector like A minus vector B, you can rewrite that expression in the form of A plus the negative of vector B. Also, this expression can be written as the vector A is equal to the sum of two vectors S and B. So simply, if this is S and this is B, their sum will be a vector connects the tail of the first vector to the tip of the second vector because it follows the triangle law of addition. So A is the resultant vector of the addition between S and B. So, an important point here is that in the subtraction of vectors, the addition laws can be used. With this in mind, I'm going to introduce the negative of a vector. So a few minutes ago, I told you when we write S is equal to vector A minus vector B, I can rewrite it in the form of vector A plus the negative of vector B. What does the negative of a vector mean? Negative of a vector is a vector which has three features. The first one, it has the same magnitude of the initial vector. So in the case of vector B, if this is vector A and this is vector B, the negative of vector B has the same magnitude. So you see here, this is B and this one is B. The second important point is that they have the same line of application, or they are parallel. So about the line of application, I will talk in more details when we start the topic of force. But at the moment, the line of application is a line along which a vector has been applied. And the third point, which is very important and is the main point that distinguishes the negative of a vector from its initial version, is that it is on the opposite direction. So let's come back to two vectors A and B. So now I want to sketch the negative of vector B on this figure. So step by step, the same magnitude, it is B. They have the same line of application. So the line of application of B, I'm showing through this dashed line, and it has an opposite direction of the initial vector. So the negative of vector B is vector minus B in this way. So I can apply the formula of addition laws when I want to find the subtraction of two vectors. When I find the negative of a vector, and just I have to apply the addition laws. If you remember, for the resultant vector, the magnitude of resultant vector in the case of addition laws has a unique formula for both triangle and parallelogram laws, which is A square plus B square plus 2AB times cosine alpha, and alpha is the angle between two vectors. Now in the case of two vectors A and B, this is alpha, if you remember, because here I'm going to use the triangle law of addition. If you remember, it was said that when the tip of the first vector coincides with the tail of the second one, we have to use the triangle law of addition. So in the demonstration of the formula for the triangle law, I show that the angle between the extension of the first vector and the second vector is considered in this formula. So when it comes to A plus minus B, now I'm going to write this formula with a bit change in the case of minus B. So I can rewrite it for subtraction. It will be A square plus B square. Now this angle from geometry is 180 minus alpha, so it will be plus 2AB times cosine of 180 minus alpha. From trigonometry, just very concise recall. We know that the sine of 180 minus theta is equal to the sine of theta, and the cosine of 180 minus theta is equal to minus cosine theta. So here I can rewrite the subtraction formula as a square plus b square minus 2a times b times cosine of alpha. So this formula, which derives from the addition law formula, belongs to the subtraction. In other words, addition and subtraction have the same nature but with different signs. The same approach can be considered in the case of parallelogram law of addition and subtraction. In the next tutorial, I'm going to solve some problems for vectors.